In this video, I want to provide the solution to exercise 3.2, question 8 from the MEI A-Level Further Maths Core Year 2 Hodder textbook. So we're asked to prove that un equals 8 to the n subtract 3 to the n is divisible by 5 for all positive integers n. We're going to do this by induction. So firstly, we want to take our base case, and as we're asked for all positive integers n, we know that our base case is going to be when n equals 1. So when n equals 1, u1 is equal to 8 to the 1, subtract 3 to the 1, which is 5, which is clearly divisible by 5. And now we want to do our inductive step. So what are we going to assume? We are going to assume that this statement is true when n equals k, i.e. we are assuming that uk, which is equal to 8 to the k minus 3 to the k, is divisible by 5. And if it helps you, we can let this equal to 5m when m is an integer. And what do we want to show? Well, we want to show true when n equals k plus 1, i.e. show u to the k plus 1, which is equal to 8 to the k plus 1 minus 3 to the k plus 1, is also divisible by 5, given our assumption that it's true when n equals k. Okay, so let's start with u to the k plus 1, which is equal to 8 to the k plus 1 minus 3 to the k plus 1. Well, we can take our assumption here, and we can rearrange this to either make 8 to the k the subject, or to make 3 to the k the subject. I'm going to make 8 to the k the subject, but it doesn't matter if you make 3 to the k the subject, the process is exactly the same. So what do we get? We get 8 to the k equals uk plus 3 to the k, or this is equal to 5m plus 3 to the k. And we notice we're going to substitute this somehow into our expression for u to the k plus 1. So notice that 8 to the k plus 1 is just 8 lots of 8 to the k, subtract 3 to the k plus 1. But we've got an expression from 8 to the k from our inductive hypothesis. So this is 8 lots of uk plus 3 to the k, subtract 3 to the k plus 1. If we expand that out, we get 8 lots of uk plus 8 lots of 3 to the k minus, well, 3 to the k plus 1 is 3 lots of 3 to the k. So we have 8 lots of u to the k, 8 lots of 3 to the k, subtract 3 lots of 3 to the k is 5 lots of 3 to the k. And we can see that this last term definitely is divisible by 5. Divisible by 5. And this term is also divisible by 5 by our inductive hypothesis. So that whole expression has a factor of 5, so is divisible by 5. And if that's not totally convincing, we can write u to the k as 5m. So we get this is equal to 8 times 5m plus 5 times 3 to the k, and then take a factor of 5, which gives us 8m plus 3 to the k, and we can see that there is a factor of 5, and so this is divisible by 5. Again, note we need to be sure that 3 to the k is an integer, but because our base case was n equals 1, when k is greater or equal to 1, 3 to the k is an integer. So what have we done? Well, we have shown that un is divisible by 5 when n equals 1, and if un is divisible by 5 when n equals k, it is also divisible by 5 when n equals k plus 1, And so un is divisible by 5 for all integer n greater or equal to 1.